Hey, this is Don for Padlock Technologies again with another video. This time we're going back to Palo Alto's to talk about site-to-site VPNs and how they differ. Well, they really don't differ now, but they used to differ from Cisco site-to-site VPNs. So backstory here. Now, Cisco, before they implemented route-based style VPNs, which is what Palo Fortinet uses, Juniper uses route-based style VPNs. Mostly every other vendor uses route-based style VPNs, but for a long time, Cisco refused to use route-based style VPNs. They were really pushing what's now legacy crypto map style VPNs, which you would have to say your encryption domains and all that good stuff, right? But now with the cloud, even the cloud uses route-based style VPNs. So they kind of had to force Cisco to move into the new dimension here and just say, hey, we all use route-based style VPNs. You need to start implementing route-based style VPNs in your devices. Now, this was in ASA, but it was on a later code. But again, ASA is just 1 through 4. I'll say 1 through 3 mainly, but it's not a next generation firewall unless you slap in the source fire module, which nobody's really doing that nowadays, um, or you get the FTD. Now, I believe it was 6, was it? I think it was early 7. Early 7 implemented the route-based style VPNs, and from that point on, kind of made Cisco FTDs in terms of VPNs neck and neck with everybody else at this point, right? Because Cisco was severely lacking in that department when it comes to route-based style VPNs, because trying to get a route-based style VPN to play nicely with the old legacy, which is now legacy crypto map style VPN, was a pain in the butt. You had to worry about proxy IDs on the other end, the other VPN headpoint. And if the proxy IDs weren't correct, tunnel wouldn't come up. It was all this weird stuff you had to do to get CryptoMap to play nicely with route-based style VPNs. But now that they have route-based style VPNs, everybody plays nice, because if you ever did a GRE tunnel, or if you did an IPsec tunnel, pretty much is the same thing, right? To the point where you can do route-based style VPNs with routers, right? And that's what's in this lab as well. So let's go to the lab, and then I'll show you the configurations from the Palo Alto side. And then I'm going to focus really on this zone-based firewall right here. So this is basically zone-based policy firewall. If you've never seen that before, you have no idea what that is. I think I did a video. If I did, I'm going to put a card right above. It's probably going to cover my face or something like that. And it will point you to the zone-based policy firewall. If you're going for your CCIE security, you need to know about zone-based policy firewall, because you're probably going to need to implement that in the lab. Now, what we have here is we have Palo right here, my DC1 Palo, which is my internet firewall, and my VPN firewall. In the real world, it would not be a singular device. I would have HA here. Then on top of that, if I wanted to break out both functions, so internet versus VPN concentrator, I would probably split out those functions from a design standpoint. So if there's anything like, hey, we got to reboot our VPN concentrator, it doesn't take everybody's internet down until it comes back up. So you kind of split the jobs in half. So one box doesn't do both, because you don't want to, you have to deal with this thing called fate sharing, which is basically if both functions are on the same box, if something goes wrong with one, it messes up the other function, especially if you have to do a reboot. So you want to kind of avoid fate sharing. So from a VPN standpoint, site-to-site VPN standpoint, we have a site-to-site in the Canadian PA. We have one in Washington. We got Wayne. We have one off the zone-based firewall. We have one for this Bluebell firewall here. And you guys probably can't see it, but there's a bunch of lines that say site-to-site VPN. That one. This says RA VPN for my Global Protect up here. We'll be talking about Global Protect 2 in a later video. We have site-to-site here, site-to-site Canadian, and then our Canada, and then we have the site-to-site in Bluebell. So what's the difference here? So we're going to log into DC1 so we can go over how to configure a site-to-site VPN on a Palo Alto, and then I'm just going to focus on the branch-based, zone-based firewall, because the PAs are pretty much the same once you see one. So let's log into one here. Hopefully, I remember that password there. We're going to save this for future reference. I do not feel like typing that in all the time. Now, you also can do cert-based authentication on the Palo so that it will ask you for a certificate and you just use a certificate to sign in. That's more secure than username and password. Probably, if you want to see a video about that, put that in the comments and I'll configure it here and then show you how to do it on the Palo. All right. But you definitely have to have the certificate. So you have to trust the CA and you have to have your own user certificate on here to do that type of authentication to the dashboard. So for a network, from a network standpoint, for a site-to-site VPN, there's a couple things that I usually do, right? For one, zones, right? So I have a bunch of zones here, right? I have site-to-site Bluebell, site-to-site Branch, site-to-site Can for Canada. Oh, I keep saying Canadian, but one for Washington, one for Wayne, right? Now these are going to be all layer 3 zones, and we need to create our tunnel interfaces that matches the zone. Remember, this is route-based style site-to-site VPNs. So the next thing you need to do, create your tunnel interfaces. You have tunnel interfaces all here, right? We have our main one here for our global protect. And as you can see in the comments, it says tunnel for global protect users. Then every other tunnel is pretty much a /31. Now, a lot of people, depending on who you ask, they either like /30s or /31s. I use /31s between point to points to conserve IP space. Now, if you use the /30, you're giving up 2 IP addresses, right? You're giving up 2, which is the subnet and then the broadcast address. With /31s, you can do a 0 and a 1. And as you can see, on all of my tunnel interfaces, I'm using a .0, right? On the other side, they're .1s, all right? So once you have your tunnel interfaces set up, all that's good to go. Now we can start talking about building the tunnel. Now, the easiest way I can tell you to do this is start from the bottom up. It's not top down, right? This is where I think Palo should have kind of rearranged their menus for the way that you like someone configuring a site-to-site tunnel would think, right? So you would start with your phase 1 configurations, right? That's to start the communication tunnel to share the keying information. So that's your phase 1, right? Then you do phase 2, which is going to take that keying material and then going to protect the data tunnel, right? And then you tunnels at that point, right? Data's passing at that point. Now in the Palo Alto world, I would have had it for the network profiles. Remember, everything is a profile. I would have IKE crypto, then IPsec, then IKE gateways, right? And then probably IPsec tunnels. Well, since this is a profile, I can see why they didn't put IPsec tunnels in there. But I would have phase 1, phase 2, then the gateway in that order, right? Instead of having the gateway, IPsec, and then ICAV2, ICAV1, or IKE, sorry, which is phase 1. Because what you have to do is you have to build your phase 1 first, which is this IKE or IKE crypto profile, which I did here. Now, Diffie-Hellman, that's going to be the thing that's going to do your keying exchange. It is not the pre-shared key. That is to authenticate the the endpoint. That is not the actual key that's used to encrypt the data. So that's another thing if you're doing CCIE studies that you need to know from the jump. The pre-shared key that you share between the VPN headpoints is just to authenticate the VPN headpoint or headend. It is not the key that is used to encrypt the data, right? So Diffie-Hellman group 14. Now, if you know anything about Diffie-Hellman groups, 14, 19, and they're probably going to deprecate 21. But these are the elliptical curve algorithms, right, for Diffie-Hellman, which is more secure than the, like 5 is deprecated now. But 14, 19, or 21, that's what they usually got in there. Now, I know Cisco has 24, but the more you go up, the more overhead there is on Diffie-Hellman or your traffic. You don't want to go too far. At bare minimum, 14 is your minimum there for my suggestion. So then from an encryption standpoint, I'm using the GCM cipher, right? So I'm using AES-256 GCM. The reason why we're using GCM because that is the newer style encryption algorithm that keeps, it also combines your integrity algorithm because your integrity algorithm is basically SHA, right? It's going to be SHA. Nobody's really going to use MD5 because MD5 is susceptible to collision attacks If you don't know what a collision attack is, it's basically you take some data, you take data, you put it in a hashing algorithm, it comes up with a hash, right? Now, you can take a different piece of data, put it in the hash, and it comes up with the same hash. That's not supposed to happen, right? Because it's bit by bit. So if you change one thing in the data, it's supposed to change the hash. But if you put two different pieces of information in the same hashing algorithm and they come with the same hash, that is not supposed to happen, right? So GCM, and that was a side quest, by the way. GCM includes that integrity algorithm in there, right? If it was IKEV1, it would just be, they just call it hash, but integrity is the same thing, right? Because it's supposed to make sure that the data has not been modified. Um, so when you do GCM, you don't have to pick an integrity algorithm. Now, Palo Alto calls it authentication, all right? That's what they call it in here, but it's integrity and hashing in the Cisco world, okay? So this is your phase one, so they have to match on each side. Now, with IKEV2, you can pick multiple, right? I just did one of each, but you can pick multiple and the first match wins, right? Whatever matches win. Now, after you do that, you do your phase two, which is your IPsec profile, right? So think of this as your transform set on a Cisco device, right? It's a transform set. So phase two did the same GCM cipher, so we don't have to do a integrity algorithm. Again, they call it authentication in Palo Alto. Cisco, they call it either a hash or integrity, right? Depending on, and I'll show you when you look at the router configuration. For IKEV2, I don't have an integrity algorithm, but if you try to configure it, it is not called authentication. They call it integrity. So next one here is our Diffie-Hellman group. So this is PFS, which is perfect forward secrecy, which basically runs the Diffie-Hellman algorithm again, so that the original Diffie-Hellman key is not used. The key material from phase one is not used in phase two. So you just run Diffie-Hellman again and get a new key that's actually going to be used for the encryption of the data in that phase two tunnel. Once you do all that, next thing you got to do is the IKE gateways. And if I'm going to talk about configuring site-to-site VPNs like route-based style VPNs, Palo Alto is probably the easiest to figure out. If you just looked at it for the first time and you knew a little bit about Palo, you can pretty much figure this out. Um, uh, Fortinet is pretty simple, and Cisco is simple once you understand the logic of. If you did it on a Palo, you can do it on a FTD, and you can do it on a FortiGate. It's just where's the menus at, right? I'm gonna keep reiterating that so you don't think this stuff is hard. So I will use the branch because that's the one with the router. So all I did was you usually do naming conventions. Name it something that makes sense when you see it. Don't name it something goofy that you got to ask questions about where does it go to, or you got to dig into the configurations. So I'm gonna do IKEV2 only. Now you can do preferred, but IKEV2 tunnels is where you need to go to. Nobody, you really shouldn't be using IKEV1 unless the other end cannot do IKEV2. So then you point it to your interface, right, where you're going to use as your local identifier, then your peer address, then your pre-shared key. You could do certificates if you want, but then you have to have the same certificate on both sides, or you need to have the CA that signed the other certificate. You need to trust that so that when I present the certificate to you, you trust it, right? If you don't have the CA that signed my certificate, I don't trust you because I don't trust who signed you. After you do that, you go to advanced options and you pick your phase one algorithms. So that's phase one, and you say okay. So now you have your gateway set up. So now you tie this all together into a IPsec tunnel. So we're gonna go to IPsec tunnel. Now you could do GRE, but might as well do the ICAP, the IPsec tunnel for the you know ESP encryption. Now you technically can do um, tunnel protection on a GRE tunnel, but I just didn't. I decided to do IPsec to IPsec. So we go to our branch tunnel. We name it site to site branch tunnel. I'm using you now. This is where you call your tunnel interface. This one is going to be tunnel 6. You call your gateway. So this is where you tie your phase one into phase two. And then you say, here's the phase two, right? Crypto profile. Sounds familiar, right? So if you're ever doing a tunnel interface and you do uh, tunnel protection, IPsec profile, whatever the profile is, that's what this is, right? And that's why I said route-based style with tunnels. So you could see where Cisco kind of had to go this way because everybody's doing this, right? And it's a lot simpler to set up. Now, proxy IDs. This is what you had to do when you had crypto map and route-based talking or trying to establish a tunnel. Without this proxy ID, it would not come up, right? So, and this would you would go add, and then you would put the local subnet on from the PA standpoint, and then the remote subnet from the ASA standpoint. And then once you did that, the tunnel would come up. But before then, the tunnel would never come up, and you would have these weird error messages on the. You would do troubleshooting, and you would see, oh, okay, well, we need the proxy ID. So that's why if you're doing the FTD, the Palo, just use route-based style. It'll save you a ton of trouble. Once that's up, next thing you have to do is obviously your routing. So you need to go into the router. We're going to the default router, and then we have a static route. I'm using static routing, but you can do dynamic routing protocol or BGP at that point. Now you got to be careful with BGP because if you have a bunch of tunnels and you're doing BGP over the top, if it's you might not want certain subnets to be advertised out. So then you have to manipulate BGP to only advertise the local subnets that you want and not use the other subnets as transit, right? So you'd have to make an export rule, and then export rule would do either a AS path access, AS pass, AS path access list to filter out that stuff, right? And I did do a video on AS path filtering, I believe. I'm not gonna put a card because I can't remember off the top of my head. But static route for everything. Same thing on all the other PAs, pretty much the same setup, right? Then once that's done, and the last thing is your policy, you don't need a NAT policy again because there's no need for NAT. Now, I'm gonna tell you flat out, I would never do this in real life, right? I would not just let this thing be open to any, right? That's bad security posture. But for the video, I did it so you guys can see this, right? I would, but it's funny. You probably asked me, do I see this stuff in real life? The answer is yes. I've seen plenty of firewalls with just wide open VPN tunnels, meaning you trust the other side. And I've seen people get security incidents because that other side got a incident which carried over to them because they did not lock down their policies enough to only allow certain protocols to get through. They just allowed anything and then they got hit with whatever happened over there. So again, this is where your third party management comes through, right? You got to make sure they're using adequate security controls to prevent you from getting hit with something, right? If you don't know what they're doing, you need to lock it down as much as possible, enough that you can do business and let data flow and not be hit by whatever is going on with them. All right. But again, third party vendor management is what you need to be doing anytime you're going to attach your network to somebody else's network to do some kind of transaction or something like that. But for this purpose, as you can see, here's my DC1 to branch, basically bi-directional rule for anything, and I'm allowing it. And as you can see, I got some hits here, so obviously the tunnel's up and running. So that is the Palo side. What does it look like on the zone-based firewall side? So zone-based firewall is basically it's an older method of making a router into a firewall per se. Now, I did do a video on this. I'm going to put that up here somewhere. It's probably going to cover my face about zone-based firewalling. So learn that before because this is going to sound like just gobbledygook if you don't know what zone-based firewalling is. So I have my zones here. Now, the tunnel interface is in my LAN zone. So intra-area communication is allowed to go by default. This is why I didn't have to create a zone pair. So if I do show zone, let me think. I think it's zone pair or zone policy. Sorry. So is it zone policy or policy base? I can't remember off the top of my zone. I don't want to do that. Is it zone pair? I don't want to do that. Well, actually, I do. So we go LAN. So you see my tunnel interface there, right? So you see the tunnel and the inside interface is there. And then I think it's show zone pair. I haven't did zone based policy firewalls in a while. Zone pair security. I think it's LAN. Is it LAN to WAN? Getting a little laggy here. Or SLAN destination WAN. All right, so that's my zone-based policy there. Now I could do show run to get deeper in there, but I'm just showing you that we got zone-based going on. I'm trying to remember what is no, I think it's policy. Oh yeah, show policy firewall, I believe. There we go. Couldn't remember off the top of my head. So zone config, and then let's look at zone pair, LAN WAN, LAN WAN, I believe. That's LAN WAN, zone pair stuff. This is my inspection going out that way. Again, this is LAN going to WAN, but since the tunnel is in LAN, I don't have to worry about my zone-based firewall getting in the way. So now if we do show crypto, I'll just do show run crypto. Hopefully I don't have other things running from a crypto standpoint. So let's just look at crypto. All right. So here's the crypto. Here's my phase one. So again, matching what I have on the Palo side, which is AES GCM 256, AES GCM 128. So if I had 128 on the Palo end, it would disregard the 256 and the match would be 128, and then it would come up on the 128 for the encryption. Now, as you can see, this PFR is something that you just have to put in for Cisco routers, and you have to do it on FTDs as well when you do ICAV2, but you do not see the integrity here, right? Now, if I picked AES 256, then I would have to put an integrity algorithm here and the PFR, all right? And then we have group 14, which is our Diffie-Hellman for the phase one tunnel communication, or the phase one key exchange. Then we have our policy that references the proposal, right? Now there's other things you can do in here like match a front door VRF, which is match F, I think it's FVRF, yep, match FVRF, and then you have to give the VRF name. You can match an interface, you can do a whole bunch of stuff. Then we got the key ring, which has the key in here, but it's a lab, so I don't really care if you guys know the key. Um, this is your key ring for ICAV2, which is here, address, pre-shared key. Now, what you can do technically in this one is you can have a pre-shared key for remote and pre-shared key for your local, right? So you can have asymmetrical keys. They don't have to be the same in ICAV2. Then we create our ICAV2 profile, which we match the address. This is matching my local address. This is matching the remote address. So that's the identity for the remote peering. We're going to say authentication, remote pre-shared key, local pre-shared key. Again, this can be different, or it can be asymmetrical. I could say, okay, the remote authentication is Palo, whatever this is, and then my local one is Cisco, whatever, something. I could do that if I wanted to. Then we're going to reference the key ring that I created here. And then we do our transform set, which is phase two technically, right? On a router, your transfer set is always going to be your phase two. So your IPsec transfer set, whatever for the GCM cipher transport mode, you don't want to do tunnel mode because since this is a tunnel, we don't want a duplicate header, right? We don't want to duplicate the header. Now, technically, you would do this on the GRE tunnel, right? You would do transport mode for GRE tunnel to avoid the duplicate header. Um, but I just did it here. Then we created the profile, which is the transfer. We just set the transfer set. we set the ICAV2 profile, and then we run PFS here, which is running Diffie-Hellman again, group 14. And then we tie this all together into the tunnel. So now we have our dot one, which is a /31, like I said before. I set the MTU, maximum transmission unit, to 1400, and then I adjusted the maximum segment size to 1360. Now you're probably going to ask, why would I do that? And if you're studying for your CCIE, you need to know this. So there's 20 bytes for TCP and then 20 for IP, right? So that's 40. But what you want to do is, you're doing this to avoid fragmentation, right? So what you're trying to do is, you're trying to make sure things don't get uh, broken up or fragmented because it's too big, right? So by default, 1500 is your size, right? Unless you're using jumbo frames, but we're not talking about jumbo frames here. So you're using 1500 is your size. So if you set the MTU to 1400, but then you said your maximum segment size that you can send is 1360, you account for TCP and IP, the 20 bits for each of those, which is 40. So it keeps it within the 40 range, but ultimately it keeps it under 1500 for being fragmented. When you're creating your GRE tunnels, you'll probably have to do that in the lab, probably, right? To avoid fragmentation, because if you run protocols over top of it, like now if you were doing GRE, you have to account for the GRE bits as well. Then if you're running EIGRP or OSPF or any of that, you have to account for that to avoid, especially with EIGRP, you want to avoid the fragmentation as much as possible. I'm doing a lot of side questing in this video as well. Then we add the zone here, right? We add it to the LAN zone. We're going to make this a IPsec tunnel. So this is a IPsec IPv4 tunnel. This is not like, there's a whole bunch of tunnels you can create. This is not GRE. This is not IPv6 and IP. That's a whole nother topic. Then we set our destination, but we do our tunnel protection first, and then we set our destination, and then tunnel comes up. So if we do show interface tunnel 0, this will tell you a lot of information, but what we are mainly looking for is, this tells you this right here, tunnel protocol transport. This is an IPsec tunnel, pure IPsec tunnel. If this was a GRE tunnel, you would see GRE here, right? Then you'll see it's up, you see the source, see my destination here, see a bunch more information here, tells you exactly what the IP is. What else do we got here? We got packets moving in and out of this thing. We don't have any collisions. So we have our inputs right here. So we're good to go there. And has the IP profile connected. See, this is where you get all this information from. And last but not least, we'll do show crypto session detail. We'll give you a lot more information here. But this will give you your phase 1 and phase 2 in one thing. So we have up and active. We have our phase 1 here. And then we have our phase 2 here. Now, the reason why you see SA2s, right? Because if I do show crypto IPsec SAs, you're going to see your security parameter index. So you see one for inbound, one for outbound. So if we do show crypto IPsec SA, there you go. So here's the one security parameter index for inbound traffic. Here's the other one for outbound traffic. All right. Every time you do a tunnel, if this was a crypto map style, you would actually see the subnets, but since we're doing a route-based style, they're always going to be 0000. You see some decaps and end caps, so we're good to go from there. If you want to see phase 1, it's going to be ICAV2SA. This is the phase 1. Here's my GCM that we said we're using. We're using the key size of 256. The bigger the key, the stronger the encryption. PFS is going to be 256. Here's our Diffie-Hellman. Our authentication is PSK. We're verifying with PSK. And we're good. No front door VRF on this one because we didn't match any front door VRF there. So as you can see, tunnel's up and running, and we have a machine branch user behind the scenes. All right. Let's open this up. Hopefully it does open up. Oh, it does not open up. Why am I not surprised? Um, from a, you know what? Let's just, I don't think this is going to work with guacamole, which is the HTML version of this. But every time I try to use guacamole, it just does not work the way it's supposed to. Let's go branch users. Oh, all right. Well, luckily, because usually if I had this on login, the login doesn't work. So as you can see, if I go to stuff.com or whatever, stuff.com comes up. Hopefully nothing crazy comes up there. Um, but if we look at DNS, whenever this wants to come up, this one is running slow here. So if we look at DNS, and can we expand this just a little bit? Come on. It's not going to expand too much. So if we do an NS lookup, our NS lookup should be going to our domain controller, which of course this is going to take forever to do. All right, so that's our domain controller. So now if I just go like, give me Google, there we go. So we were able to resolve it because that is our domain controller that is down here. So right here is where it got its DNS from. And that also means we don't have to do this anymore. If we look at the rule, that was 622. Give us some time here. Yep, and there we go. It just went up from 622 to 636. So that tells you that from the PA side, traffic is going, and from the other side, we saw the NCAPs and DCAPs was incrementing as well. So that was the site to site on Palo to a zone-based firewall Cisco device, right? Palo to Palo, pretty much the same thing. Palo to Palo was pretty much the same. So I didn't show you all the other Palos because it's pretty much the same thing. So that's it. That's site-to-site VPN, route-based style VPNs on a Palo Alto. Hopefully this video was informative. Did take a while because I had to set some of this stuff up. But I hope you enjoyed it. Don't forget to share, comment, like, and subscribe. Also, if you got questions about some piece of technology, there's going to be a video bumper at the end of this video to where you can send a request. I don't know everything, but I do know a lot. If I plan on doing a video for you, I will let you know through the email, and just be on the lookout for the video response here. This is Don from Padlock Technologies again. Thank you, and have a nice day.